So a very good morning, good afternoon, or good evening to wherever you are, wherever you may be. All right, so today we are going to go for a 6400 series, Agilent LC Triple Quad webinar. Right. My name is Kelvin, and I'm one of the trainers from Agilent University for this product line. And we're going to have a overview, maintenance tips covered over this about 45 minutes. All right. Right beside me, you can see here, I have a 6470A series model. Over this course of this short webinar, I'll be introducing to you this 6470, as well we'll be having a look at the internal of a 6460, an old 6460. Right. So without further ado, let's get to the objectives. So we're going to have a look at a recognition of the instrument that you may have in your lab, or you may be intending budgeting to purchase for your use. So this instrument is used in many areas, ranging from food safety, pesticides analysis, to even pharmaceuticals analysis, to even so-called research R&D in the academia. So it's important to recognize the elements of the instrument, as well as to have a look at the workstation PC software applications before we go for the general usage and maintenance tips. So over here in this slide, you will be able to see that we have the range starting from the 6420, 6430, right, and 6460, 6470, which is a general workhorse in most labs nowadays, to the 6495, which is the most sensitive in the market. It's most sensitive because of the iFunnel technology that's present in this product, right? And in this slide, you will be able to see the specifications. As you would have seen, the 6495B, right, is the most sensitive in a sense, having a signal to noise of 150,000:1. There is an injection of 1 picogram of reserpine onto using the MRM mode. But the 6495C, which is now in the market, there is a further enhancement to that, to close to about 550,000:1. And if we are going to look at the 6470, right, 70A, and now is the 70B, right, 70B, we are now having a sensitivity level of about 350,000:1. So there's quite a big improvement. Over this slide, you also can see that there are some consumables that you might need to take note of if you're using the various kinds of models across in your laboratory, right? The capillary style itself are mainly different. If you take a look at the 6470, we're still going for a single bore capillary, to the more sensitive 6495, which requires a hexabore capillary, which is about 9 cm or so in length. And in terms of the collision cell style, right, you will be able to see that some of the product lines are based on a linear design. While over here, you can see the 6470A, it is a more smaller footprint, and it is basically on a curved collision cell design, right? You'll be able to see the schematics in the next slide. And of course, what is the mass spec without having a good vacuum? We will need good working rough pumps, some of which you can see that we have 1, and most of it will be having 2, right? And only by having a good vacuum, the ions will be able to be so-called fly through the quadrupole, selected, right, and reach the detector. So in this slide, you will be able to see the details regarding the schematics and the design of the various models of the mass spec, right, ranging from the 6430, 6470, which is now the curved design. We'll be having the so-called sample introduction. The liquid will be desolvated in the desolvation assembly. Over here, you can see the spray chamber. All right, the nebulizer will be sitting right over here, and we'll be having liquid spraying. And of course, because of the AJS, right, the AJS technology, the jet stream technology, we'll be having a superheated shaft of aerosol being sprayed out over in the nozzle over here. And of course, we'll be having the ions being sampled through within the so-called ion capillary we'll be going through, right? We'll be seeing that in the later part of the demo, right? Of course, we'll be having the capillary and then the ion optics. All the ions will go through, and the selecting of the ions itself, depending on the method, right, which is on the software, we'll be implementing it on the quadrupole. So we have the MS1 quad, and then followed through the curved collision cell, and following the MS2 quad, and finally the detector. So depending on whether you are going for a scan or you'll be looking at more sensitive analysis, you'll be implementing MRM, multimode reaction monitoring, or even DMRM, dynamic, right? Is a dynamism in terms of the selection of the window, retention time windows, right? Yeah. And then we'll be having the 6495, which incorporates the iFunnel technology, which have two iFunnels, one having of a higher to lower pressure. This is to allow more ions to be actually sampled through. Yeah. And by having a hexaball capillary, you will be definitely getting more ions going through. So this places a lot of importance in terms of the regular maintenance and also the periodic maintenance. All right, so we're going to pause here for a moment to take a look at the 6460, which is of a linear design. Welcome back, and let's resume. I'm now just standing right beside a 6460A instrument, and I basically open up the spray chamber itself. Right, you will be able to see that the nozzle itself on this instrument is a bit dark color or even brownish or dark brownish. So this is a symptom whereby it's time to really have a go at changing the nozzle insulator itself. Otherwise, it will be affecting your so-called preservation, right? And the sensitivity might be affected, right? So right now, I'm going to just remove the spray chamber, the spray shield from the spray chamber, and you can see that there's a capillary cap, right? The capillary cap, put it closer to the monitor, the video itself, right? So we can do some fine tuning. Within the cap, there is in fact a canted coil gold spring. So the gold spring also should be in a good condition typically, but if it's ever found to be so-called distorted, yeah, it's better time for replacement, right? It is a small gold spring just right within it. Yep. And you can see the capillary, the resistive capillary being this part, so we can actually try to remove it. So all these are supposed to be done in a vented state, right? However, with the new technology from Agilent, right, the instruments without a vent, full vent, that will be also part of the later part of this webinar. You can take a look at the video at your own time, right? That calls for really without a full vent, and you can be able to remove the capillary. So this is one of the most important consumables to so-called sample the ions in the first pass, right, through. Okay, so I shall leave this here. So right now I'm going to walk over to show you different parts of the instrument, starting from the calibrant delivery system, right, where we have our two mix in this bottle, and the valve that is actually diverting between the LC to mass spec or even to waste. So this is working through this calibrant delivery valve, or even drawing the so-called two mix. Right. And what you do not see that's right inside this is of course the turbo pumps that are actually hidden in there. Right. We do see the back end of the pump, the 5-flow pump, right, over here. And I shall go over. And a brown tubing, you may be wondering what this brown tubing is for.
So when we are looking at running a tandem quad or triple quad, right, we'll be having collision gas through, a pure collision gas through. And this is where the gas is actually going into your MS2, right? And I shall remove the cover so that we can take a further look. Right, so I have the camera to zoom in on the various parts. As you can see, beyond the desolvation chamber, which holds the capillary, we have the ion optics within this window here. See the ion optics. In fact, there are this bit of octopole 8 rods within it. Really a close look. Okay, perhaps as best as we can. Zoom in, right, within it. Right, so this is the ion optics, and that's where our MS1 is. So this is the previous design whereby things are still linear, but the parts within it, okay, may be almost similar. Okay, so you have the MS1, and you have the collision cell, which is the MS2, and of course we have the MS3. Yeah, so MS, and of course the detector. So this is the part of the DCD detector. Right. So this is what picks up the ions and translate that into signals. Right. So we have a good look.
So I hope you have a good look at the internals of the 6460. First, apologies, a bit of a correction in terms of the terminology. Right. So we are having two mass analyzers. So we'll be having actually an MS1 and an MS2. So LC-QQQ. One is called QQQ in this case, when we only have two quadrupoles that are in fact on the instrument itself. Because the second Q is actually part of the so-called the collision cell. That's why it's called QQQ. So Q1 for the first quadrupole, which is a mass analyzer, and this samples in the mass ions, depending on the methods that you set, be it a scan, or perhaps you're looking at an MRM, which is a specific ion. Right, and then we have the second Q, which is the collision cell. Right, the collision cell itself is where the influx of the so-called the collision gas flow will be going into the collision cell, and that's where the dissociation of the so-called first ions that are selected, is going to happen, and the so-called the last or the second, the mass analyzer itself, which is the Q3. Right, so this is the one that is going to be another specific selection. Therefore, when you have multiples of this kind of so-called reaction monitoring, we term it MRMs. All right, so I guess that's enough about terminology. Right. In terms of the ion sources that are supported on this series of the LCMS, right, we have the latest, which is jet stream. So the jet stream are available on the 6470 and also the 6495. And of course, we have the so-called typical, the traditional ESI. This is the most basic. And we have the APCI, the multimode, which allows you to do the ESI and APCI at the same time. Right. On the QQQ analyzer, so these are the various parts that we have seen on the linear design 6460. You have the ion optic region, whereby of course your capillary will sample the ions, and the schema which samples the ion beam, and we have the octopole, right? By applying so-called correct RF, right, it thermalizes the ion beam itself and really focuses it, right? And we have the lens 1 and the lens 2, the RF. This enhances the high mass ions transmission. Because we'll be looking at masses over a wide range, right, depending on your application itself. So we cannot disregard the high mass ions transmission. Right? Then of course the orange region, we have the 5, 6, and 7. First, the vacuum itself is supported by the Edwards turbo pump. You have seen that in the earlier demo, which is just sitting right beside the first quad. Right, so the MS1 basically filter. So just now, as I mentioned, this is a high pressure hexapole, whereby your high purity N2, your nitrogen gas, is funneled in, and of course we have the last part, which is a detector, which emphasizes and multiplies the
so-called ions, right, to get our signal. You also have seen the so-called Singapore resistive capillary earlier on, and the latest part, the latest capillary that we have on the 6495, for example, is the hexaball. It's about half the length of the resistive capillary, right? But there are six holes on this hexaball itself. You can see the basically the V cap, the capillary itself, V chamber. And you might be interested to take a look at the video of the vac shield technology, which is the technology that I mentioned earlier on. So this allows us to do some maintenance or even the replacement of this capillary, and is applicable on the Altivo, which is really a small, nice footprint, the LC Triple Quad, and the 6470B, as well as 6495B, and now the C model, right? And the LC single quad IQ.
Every module in an LCMS system requires occasional maintenance. But when that maintenance is needed, it should be easy, not complicated, and fast to ensure the LCMS returns to full operation. This Innovation Minute will describe how VacShield ensures maximum uptime for the Altivo Triple Quad LCMS.
VacShield allows the ion source capillary to be removed and installed without venting the mass spectrometer. VacShield has no handles or actuators and is small enough to fit into the desolvation chamber without increasing the size of the MS. Here's how this innovation works. In order to withdraw the capillary, a special gripper is employed since the tube can be extremely hot. As the capillary is withdrawn, it passes a seal that allows the vacuum within the instrument's manifold to enter the VacShield valve. Further withdrawing the capillary allows differential pressure to seal the void left by the tube via two small valve elements. With the capillary removed, VacShield still allows a little air to leak into the manifold. This small leak is intentional and important since it prevents backstreaming of contaminants from the rough pump into the vacuum manifold. When reinserting the capillary, the process is simply reversed. With VacShield, maintenance is very fast and very simple.
To learn more about other innovations in the Altivo Triple Quad LCMS, please visit Agilent's website.
So what we have in this slide shows the previously 6495B, right, without the new VacShield technology. This is the one that still requires a gate valve. But basically the idea is to so-called isolate, right? So without really fully venting the mass spec. So this allows a quicker, uptime of the instrument after basically a replacement of the capillary or even a cleaning process. So this is the ion optics, which incorporates both the schema, which really focuses the ion beam and deflects off the neutrals, and the octopole itself. And the enhancement or the increment in the sensitivity for the 6495 is due to the presence of these two pressure funnels. One, which is the first high pressure funnel. So this allows really very much more ions to be going through before really going through a low pressure funnel. And then finally to the Q1 or the first MS analyzer. Right? How does this ion funnel work itself is we have the RF voltage, which focuses the ions to the center, right? And we have the DC voltage, which accelerates the ions basically to the exit point, right? Which is basically to the quad itself, right? So more about the ion optics, design of that, and the quadrupole one, which is your MS1, made out of the hyperbolic rods, right? The hexapole rods on the collision cell, or the Q2, right? And you have on the 64, 70, 95, you have a larger entrance aperture and a smaller, exit. So this basically will focus, further focus the ions into your second analyzer, which is the MS2. Yeah, and finally, of course, the Q3, which is the MS2. And last but not least, the detectors. We have the high energy diode, which basically you can set it in positive or even in negative mode to look at ions. And of course, the resources. Okay, most important, the resources for users. And where can we find them? So for every new installations, we do have this so-called resources UFD or the thumb drive itself, where we can get it to be installed onto your desktop for easy access to the e-flumerization or electronic flumerization, and further look at other available resources like even videos or even some basic manuals or quick start guides.
Okay, so after the so-called resources is being installed onto the desktop, you will get a shortcut which has really a small blue book. So I'm going to open up the one that I have on my desktop. And this is where you can see the various resources that are available to a user, right? You do get one resource on the data acquisition. So you do get a quick start guide, right? And in terms of the mass pack itself, you do get a maintenance guide, which is really animated. And you also get an e-flumerization guide for acquisition. This will act as a quick start for users, new users especially. So right now I'm just going to have a very short, we look at the maintenance guide, and you can see that once I click on browse, there is an overview. You do get some info regarding the startup and shutdown, I guess, which is really important these days, right? And you can take a look at this, right? Startup and shutdown. And you can see that, for example, the ion transfer capillaries, how to remove the capillary, regards to that, what you need. Right, in terms of disinfection, perhaps. Right. Okay, so these are really very good resources for users to have on their site for quick reference. Right. So if we take a look at the nebulizer itself, perhaps how to adjust or replace the needle. You can see that there are some information other than the tools needed. Right, a picture of it. Gloves, the images of the lock nut, right, and also quick video on this. So it's really a nice resource to have, on your PC itself, so that if you need reference, right, you can come here to have a look. Just going to show this for another 10 seconds. Yep. Okay. So I hope you have a good look at the animated maintenance guide. Yeah, it's a good resource to have. So in terms of the data acquisition, we are using the Mesh Hunter to control, to do our tunings, to be in the tuning context so that we can perform check tunes or even manual tunes. Right? But most of the time when you run into issues, you would perhaps want to fall back on a full auto tune in either the positive or the negative mode, depending on the application that you are working with. And that's where we can also, through the Mesh Hunter acquisition, perform our our work list setup and edit our method to do a scan or maybe a DMRM, right? That's where we can set up and optimize our parameters manually. We do have the qualitative analysis. This allows us to have a quick look through, finding the compounds itself through the MRM algorithm, right, which is one of the common uses. And the quant itself will allow us to fall back on the reporting side to really provide a report to user like yourself, not only to integrate, analyze, but to really have a figure and a look at the amount, whether it's in terms of concentration or amount, right, of the component that you are interested in or you're targeted at. So take note that this is a targeted analysis instrument, targeted approach. Therefore, as you can see, most of the times we might be injecting quite dirty samples in there, right? It's good to have a sample prep prior, or at least do some kind of sonication, and then do the supernatant extraction or solvent extraction. This emphasizes that the PM is important, and this can be scheduled every 6 months basis or on really an annual basis, depending on your use and your needs, right? And we have a PM list for that. Proper mobile phase preparation is important for any kind of LCMS use. So ranging from single quad all the way up to end to time of flight, right? So this is to ensure that not only we try to eliminate or reduce the contamination or even the ion suppression methods, this will allow us to have, ensure that we have a good sensitivity and performance for the instrument, right? So we always try to use mass spec grade water from the from the system, right? Always use the MS grade solvents or very clean solvents. Buy the smallest volume of the additives or reagents or other modifiers, and we replace the buffer starting materials at least every year. So this ensures that you can have a fresh buffer salt for preparation. This is some quick note that's found on the LCGC forum. This about the stability of formic acid in methanol itself. So through this note itself, or this article, it does conclude that blends of formic acid and methanol, right, added together with in water, of course, can actually affect the stability. So this will affect some of your applications that are out there in the market, right? So the important takeaway is to prepare everything fresh. In terms of the LC, it is also a very important component because that's where our sample introduction is, right? And that is where also the so-called solvents are being pumped through the system. You try to limit the so-called instability through the pressure itself. You should have a very good stable baseline, and that is from the so-called pump, right? Performance itself, to having a good performing pump. And we should actually take a look at also the solvent inlet filters that are on the in the bottles itself. Flush the degasser, perform the pump maintenance either on a half yearly or even a yearly basis. Auto sampler in terms of getting good reproducibility and getting good so-called linear regression line. It's very important when you're doing calibration that when you're injecting 1 microliter, it's really 1 microliter, right? And of course, the maintenance of the detector itself, which is the mass spec in this case. So a very general PM on the typical general LC, you really take about 4 hours or so. In the next slide, you are able to see, right, on the left-hand side, right, effects, build out of buffer salts in the spray chamber itself. So this should be a daily cleaning process by any user of LCMS, right? Typically with 50-50 of IPA or even methanol and water. So give it a good, nice, clean wipe so that you do not have any issues later on, right? Some pictures about the cleaning process itself, and also, of course, contamination, which should be cleaned off. and various pictures about the different so-called the spray shield and the end cap and the cattle coil, which you have seen earlier on through the video demo. And we do need to check the depth of the needle of the nebulizer. It's a very important portion so that the spray can be of a so-called good order. Yeah, so this can be actually enhanced by adjusting with the toolkit that Agilent provides to users, to new users on a new system itself. And other operating tips are like vacuum levels, which you should monitor, because if the pumps are so-called failing, your vacuum will be affected, and that will definitely impact on your performance of the amount of ions that is going through, right? Then we need to check the rough pump oil, make sure that the pump doesn't run dry. Check tune as much as you need. It could be on a daily, weekly basis, depending on the SOP. Auto tune is, on the other hand, infrequent because usually we do it when we are facing some issues. And we hope that the auto tune can help you to overcome. Otherwise, it really means that we really have to focus on the maintenance of the system or cleaning of the internal parts. It's beyond the capillary, right? When changing sources, of course, you do have to put the instrument to standby mode, right? Not only changing sources, even let's say, for example, if you have a TQ with, let's say you're going to change the ion capillary or even clean the ion capillary, and you do have a gate valve, and you do have to use the gate valve, pull out the capillary, and before all this happens, the system has to be in a standby mode. This is to so-called bring down the temperature to a much lower level whereby you can handle, right, the internals, because it's hot, right? When you open up the spray chamber, you will know it feels not only warm, it's hot. Right? You do not want to really you will have to put safety as first priority. And the next thing is that you have to shut down the electronics. Right? So if you'd like to know more about Agilent University, we do have different kinds of education styles that may suit your training needs. We do have the standard classroom trainings. We also do have the virtual instructor lab training. So these are basically very short, just lecture style only. That means through the slides, and also availability of self-paced e-learning courses through subscription. So this could be a half-yearly subscription basis or even a yearly subscription basis. So if you would like to know more, so please visit our website. And we do also have the course calendar out there for you to download. Right. So this is a QR code. If you are interested to know more about the calendar and more information, you can scan the QR code. And typically for the mass spec courses, we do have these courses. Some of it that ends off with C. So these are full-fledged courses, classroom style basis. And the V ends off with V, for example, the 2274V. So that's a virtual course, right? So that's a virtual course. Okay. So thank you for your attention. And if you have questions, please feel free to leave them, and I'll try to answer as much as I can.
Thank you to Kelvin for that very insightful presentation. We will now proceed to the question and answer section. We have a few questions in the box, but please do feel free to put your questions.
That very insightful presentation.
So Kelvin, first question is, are there any databases for the LC Triple Quad applications?
Yes. Let me unmute myself. I hope that you can hear me clearly.
Yes, thank you.
That's good. Yes, I think that there might be a thinking that for LC Triple Quad, since it's going to be more targeted analysis, a lot of times it will be more through manual optimization or even through using our optimizer software, which is pretty good. However, Agilent does offer databases for certain applications, for example, in the forensics field or in the toxicology area. So these are actually triggered MRM's so-called database. And if you are working with environmental, we do have the water screening and PFAS MRM databases. And in terms of the food safety, right, we do have also things like the veterinary drug triggered MRM databases to support your work so that it can get you up to speed. And if you do work in the metabolomics research area, we do have also the MRM databases. If you have any interest, we are much happy to share this with you in terms of the product number. Right. Thank you.
Great. Thank you. We have a second question. Given that the G6495C is selling now, what are the key advantages as compared to the B or A series?
Right. This is a very interesting one. Because if you have seen through the video itself, we do now have the Max Shield feature. So this allows you as a user to really work with the system in terms of the maintenance. For example, if you do really need urgent need to replace the ion transfer capillary, you do have the availability of the automatic valve shut off, and this can provide you with a so-called vent-free, quite rapid maintenance process. Other than that, if you do notice that previously, most of the triple quads would come with 2 times MS40 rough pumps. So these rough pumps basically will work up to about 40 meters cube per hour of in terms of the pump rate capacity. But now with the 6495C, it is replaced with just a single MS120 roughing pump. The other key advantage is that it does reduce in terms of the gas flow turbulence, and will probably improve the percent RSD in terms of the reproducibility of your results, especially if you are working with really low dwell times. Most of the times we'll be looking at probably 5 milliseconds, or even sometimes if you have a lot of cycles to look at, it could be 1 or even 0.5 of a millisecond dwell time. So these are the times whereby having a good stable vacuum, especially the initial vacuum, would help in terms of your RSD. And the last point I wish to share is that with the 6495C, this would expand your mass range to up to about 3000 M/Z, and it will be definitely useful for targeting a high molecular weight peptides that are actually multiple charged. Right. So
Great.
I guess, yeah.
Thank you. Thank you. We have one more final question actually in the Q&A. Can you elaborate on the stability of formic acid in methanol?
Sure. So I can repeat again. This article can be found on the LCGC forum, which you can just Google online easily. The article volume is 26, number 9, September of 2008. Right. We can also share the path with you if you leave us with your details. In a nutshell, this study basically shows whenever we have a so-called acid and also alcohol in the presence of atmosphere, there could be chances of esterification. And what is found by, of course, GCMS, the ester formation, and with the decreasing formic acid, so you do have a change in terms of the pH, and this could lead to some shift in retention times. And this article was basically looking at peptides of interest, so things like bradykinin, or even methionine and capillin and oxytocin. I guess what I really learned from this article is that a clear message is to really prepare our mobile phase fresh whenever we need, especially we need some kind of buffer concentration and also pH.
Thank you, Kelvin. There are no more questions in the Q&A, so that will bring our webinar to a close. Before we do go, I'd like to remind you all, please do take a look around our virtual symposium, visit our exhibition centre and see all their booths, and visit our on-demand centre and see all our breakout sessions as well. And if you've got time, please, we'd love to hear from you and fill out our survey. So once again, thank you very much to Kelvin for this fantastic presentation, and I wish you all a very nice day. Thank you.
A pleasure.